Hi class, and welcome to chapter 17. So in chapter 17, we're talking about money growth and inflation, and you've watched a few videos and now you're to the bulk. We've talked a little bit about some things. First thing we're going to talk about today is the characteristics of money. Money must be widely accepted for goods and services. In order to be money, you have to be widely accepted for goods and services. Why? Because if you're not widely accepted for goods and services, then you're really not money. Money requires the ability to be able to what? Take away from barter and allow you to actually assign values to things. It has to be durable. How many of you have ever washed a dollar bill, a $10 bill, a $5 bill? Well, you've washed it, but if you dry it out, you can still use it. It's durable. It has to be easy to carry. Obviously, dollar bills are very light. You can put them in your wallet. You can carry them around. They're easy to carry, and they have to be divisible. You have to be able to say a dollar is worth 4 quarters, 10 dimes, correct? And then every combination whatsoever. What's inflation? Well, inflation is an increase in the overall prices in an economy. The overall, not just one price, but all of the prices. Deflation is a decrease in the overall prices in an economy. And hyperinflation, the third term, is an extraordinarily high rate of inflation. We do not want hyperinflation. Hyperinflation is something you want to avoid as an economy. And the world economies today are much more careful about hyperinflation than they were maybe in the 1930s and 40s. Price levels. Just to keep in mind, inflation is an economy-wide phenomenon. It concerns the value of the economy's medium of exchange, the dollar bill in our case, but it is across every single thing that happens. So in other words, we have to be measuring it against that market basket that we talked about earlier. Inflation is a rise in those price levels. And because it's a rise in the price levels overall of many different things in the economy, it lowers the value of our dollar bills. So a dollar may be able to purchase less than it was before because of inflation. Remember back to this equation that we were looking at a previous video where we looked at M times V, the money supply times the velocity is equal to the price levels times the output. So in an economy, if you boost the money supply and the velocity stays the same, price levels have to go up because output cannot react as fast. So when we boost the money supply, what are we doing? We're increasing the overall price levels. And by increasing the overall price levels, we are causing inflation. Inflation is when the overall price levels go up. Conversely, if you decrease the money supply, you what? You decrease the prices. If you decrease the prices, you slow down or you decrease the inflation rate. In other words, slowing down the economy. Because the left side of the equation has to equal the right, the velocity usually stays about the same, and output in the short run can't change. So the only things that really can change in those equations, as we've learned, is M and P. So this is how monetary policy works. So the velocity of money. We did talk about this a little bit before, and I just want to run through and run through some examples because I think this helps a ton in understanding the homeworks and as well as the tests and as well as why this velocity of money equation matters. So remember we had the money supply times velocity equals the price times the quantity. Well, obviously, if you divide by M crosses out on one side and M comes to the bottom, this becomes the velocity formula. In the velocity formula, if you were to look at an economy that was just pizza, that's the only good they could sell, and the Y, or the real GDP in that economy, was 3,000 pizzas, and the price level was $10 a pizza, you could calculate out the nominal GDP, which is what? The real GDP times the price level, which in this case is 30 times 10, which is $30,000. Now you have that. What we're missing is M. So we need to know what the money supply in this economy is. If we know what the money supply in this economy, in this case, we know the money supply. The Federal Reserve is what measures that for us in our economy. And we know it's 10,000. You can then take M times Y, which we know is 30, divided by P times Y, which we know is 30,000, divided by M, which is 10, and we can get the velocity, which is 3. So what does this mean? It means that the average dollar is used in 3 transactions in this period in 2012. So this is what the Federal Reserve does. They can calculate, obviously they have these numbers. They know what the real GDP is. They know what the price levels are. They know what the money supply is, and they can calculate the velocity of money. Obviously, it's not just for pizza economy, it's for our economy, which has far more goods. We're going to run through a few other examples of playing around with these equations because I want to make sure we know how to do this. The first one is the corn economy. In this economy, it has enough labor, capital, and land to produce 800 bushels of corn. So Y, the output in this economy, is 800. The velocity is constant. The money supply is 2,000, and the price is $5 per bushel. So can we compute the nominal GDP and the velocity? Yeah, we can, because what do we have? We have quite a few variables. We have Y, because we have the output. We know that V is constant. We now know that the money supply, and we know P. So we can start playing around with those equations that we just had. Well, the first thing we can do is what? We can figure out the nominal GDP because we have P and we have Y. So we know that it's $5 times 800. So we're going to get what? 4,000. Now we have the nominal GDP. Now we know the equation for the velocity is P times Y divided by M. Do we have M? Yep, we do. So we can then take P times Y, which we know is 4,000, and we know M is 2,000, and we can get the velocity of money in this very small economy with just corn, which is 2. Now, why do we care about the velocity of money? Because we like to look to see that it's stable over the long run. We want to make sure the economy is kind of churning at a very similar rate most of the time. So when we look at the nominal GDP and we look at M2, which we learned about and the previous week, you can see how they're growing over time, whereas the velocity tends to stay relatively stable. Money. So we've talked about P, and we've talked about Y, and we've talked about the velocity, and we've talked about the money supply. Now let's talk about what the price levels really do in the economy and how we can start to look to see how it affects us individually as a person. P is price level, right? The price for a basket of goods is measured in money, in our case, dollar bills. 1 over P is the value of $1 measured in goods. For example, if the basket contains 1 candy bar, and that's all it contains, and P is $2, the value of $1 is half of a candy bar. So what we can do is we can start to calculate what the value of our money is. If the price is 3, and then the value of $1 becomes a third of a candy bar. So you can start to see, as we look at the inflation rates and as we look at P over time, we can see what the value of it is and how it creates or decreases the overall basket, in this case, the basket of candy bars. As inflation drives up the prices, it takes P from 2 to 3, it drives down the value of money. In this case, the value of that dollar bill went from half a candy bar to a third of a candy bar. So by playing around and looking at P, we can start to see how inflation starts to drive our money up and down. One of the things about inflation is that it just sounds like a number until you start to think about it in terms of what it does to your actual spending power. In this particular case, in the value of money, what has happened is that the P price, when it went from $2 to $3, inflation, the value of that dollar in terms of a candy bar became what? Smaller. We have less candy bar per dollar. The money supply, as we know, is determined by the Federal Reserve banking system. And in this model, we are assuming that in general, the Federal Reserve sets the money supply and they know exactly what's happening with it. In the model 2 that we're going to look at today, the money demand, which is what? Refers to how much wealth, money, people want to hold in liquid form meaning actual physical money, depends on P. Why? Because an increase in P reduces the value of money. So more money is required to buy goods and services. So remember how when P went from 2 to 3, we went from half of a candy bar to a third of a candy bar? Well, if you think about it that way, if the overall grocery basket, etc., the basket of every good, and it should be beyond grocery, goes up, then it increases the amount of P that as P goes up, we need more and more money to do what? To buy the same goods and services. Because when P became 3 and we could only buy a third of a candy bar, now in order to buy that same candy bar, we needed $3, where before we only needed $2, right? Thus, the quantity of money demanded is negatively related to the value of money and related to P, and positively related to P. So in other words, what we just talked about, remember that example? So the quantity of money is negatively related to the value of money. Okay, so as the value of our money became less, we needed more money to buy that candy bar. The positively is because as the P went up, we needed more money. Other things being equal, always other things being equal, right? So for example, if there's a 1% increase in the price levels, there'll be a 1% increase in demand for money. Very similar to our candy bar example. What are the other things? The other things include real income, not nominal, but real income, interest rates, and the availability of ATMs. If all of a sudden all the ATMs in the country went away, the demand for money would change drastically. So how do we graph this? You knew this was coming, didn't you? We graph this by looking at the value of money, which is 1 over P, and the price levels. And what we're saying here is that the value of money rises as the price level falls. So as we went from a quarter to a half, and the price level went from 4 to 2, what happened? We got more value out of our money. So as the price level goes from 2 to 1.33, the value of what we can get for our money goes to 3/4. So whereas before, when the price level was 2, maybe we could get half a candy bar. Now we can get 3/4 of a candy bar. When we go to 1, so the value or the price level has gone from 4 to 2 to 1.33 to 1, we're to the point where, guess what? Now we can get a whole candy bar. The Fed sets the money supply. It's some fixed value regardless of P. The fall in the value of money, or the increase in P, increases the quantity of money demanded. Why? Because if money is worth less to us, then what happens? We need more of it. So what ends up happening is you have this relationship between the two, where the money supply crosses the money demand at some point. And at this point, we can figure out where P should be to equate to the money supply and the money demand. So this is the equilibrium value of money and the equilibrium price level. So at this money supply, the Fed said, and at the demand that we have for our money, we end up with the equilibrium price level P of 2 and equilibrium value of money of 1/2. So why do we create this thing? Well, part of the reason why we create this is because it allows us to see what happens when money is injected or taken out of the economy. If money is injected into the economy, the Federal Reserve is increasing the money supply. How do they increase the money supply? They have to buy bonds, because when they buy the bonds, they give the people who hold the bonds money. When they give them money, what happens? There's more money in the economy. The other way they can do this is by reducing the federal funds rates, right? The amount of money the rate in which people borrow money from the Federal Reserve. When they do that, the money supply moves outward. And let's pretend that the money supply went from 1,000 to 2,000. So the money supply is a straight line, right? So it moved from 1,000 to 2,000. But now, where does it cross the money demand? What ends up happening is the value of money falls as the price increases. So the Federal Reserve, by increasing the money supply, has done what? It created an excess supply of money. When it does that, people reduce or get rid of their money. So the Federal Reserve increased the money supply, causing the P to rise. The initial P, then you had the increase in the money supply causing excess supply of money. People get rid of their excess supply of money by spending it on goods and services or blowing it to others, which of course would be when they put it into savings, which then gets loaned out. This results in an overall increase in demand for goods in the economy because either you're spending your money and or you're loaning it out and somebody else can spend it, but either way, there's an increase in demand for goods. But remember back to M times V equals P times Q or Y. That particular Y cannot increase overnight. You can't increase the quantity of goods available. So the supply of goods has not changed. So the only thing that can change on the other side of the equation is P. So P has to rise. Now, obviously, other things happen in the short run, which we're going to study in later chapters, but that gives you an idea of how the Federal Reserve can increase or decrease the overall price level by doing this. In theoretical objective would say that nominal and real variables differ. They're separated, right? They're separation. They're not really related to each other. Well, Hummel and other classical economists suggested that the monetary developments affect nominal variables but don't affect real variables. Why? Because nominal variables measured monetary units at that particular time. So the nominal interest rate or the nominal GDP or the nominal wage are all happening now. So when inflation happens or any kind of change in the variables in that equation, what's going to happen? It's going to affect the nows. Real variables, i.e. real GDP, real interest rates, real wages are measured in physical units. They happen they're adjusted over time, and thus they are not affected by what? Monetary developments. So, if the central bank was to double the money supply, Hummel and other classical people contend that the nominal variables, including prices, would double. Okay, because they doubled the money supply. We've looked at those equations. But real variables, including relative price, would remain unchanged. So even though the prices would double, they feel that relatively nothing would change. Well, Hummel did have some good theories. It did make sense that he was saying things that kind of did make logical sense. But how does this really work? Like, that sounds kind of theoretical, doesn't it? Well, let's take a look at an example and see if it really does work. So what he was saying was money was neutral. So he was basically proposing that the changes in the money supply don't affect these real variables. They're neutral. So if we doubled the money supply, it would cause the nominal prices to double. But what happens to the relative prices? Okay, so we're going to look at some CDs in terms of pizzas. So in this economy, there are basically two things you can buy: CDs and pizzas. CDs are those things that you used to get music on. $15 for a CD, $10 for pizza. So we can basically measure our pizzas per CD as 1.5 pizzas per CD. So what are we looking at now? We're looking at the relative price. Relative between CDs and pizza, the prices have stayed, they're relative. And we have a relationship, and the relationship is 1.5 pizzas per CD. It's a relative measure in physical units. What if the nominal price increases? So now the nominal price increased. So we double the price. So now a CD costs 30 and a price of pizza costs 20. The relationship between pizzas and CDs, the relative prices have not changed. It's still 1.5. This is what they are talking about when they talk about the neutrality of money. That even though prices have doubled overall, the relationship between prices within our economy has not really changed. The relative prices have not changed. I think it helps to look at the actual numbers. At least for me, it always has. The theory is always kind of like, really? Hope it helped for you. Sorry, I think I've got the same slide twice, 3 times. I wonder what's going on. Let's go ahead. So the money neutrality basically says the money supply grows and prices go up. But the real GDP, employment, jobs, investment relatively stay the same. So let's go back to an economy and take a look to see how we might do this. So remember our economy with the whole notion of what? Corn. Sorry, I got to catch up with us. Here we are. Sorry. So here we are in the corn land. So the economy has enough labor, capital, and land to produce 800 bushels of corn. V is constant. The money supply was 2,000 and the price was 5. So if the Fed increased the money supply by 5% to 2,100, we can compute the values nominally. We can compute the inflation rate. And then we can go on to example 2. So what do we have? Well, we calculated this a little bit, but now we have to calculate it for the increase. So what do we have? We have P, we have Y, we have M, and we have V. So we can compute the values. So we can say, all right, M is now what? 2,100. We already have V. So we know that the nominal GDP in this economy is going to be slightly higher because the money supply went higher, right? So we now know that this is going to be what? It's going to be 4,200. So given the fact that we know that M times Y has to be equal to, M times V has to be equal to P times Y. And we know that M times V is equal to 4,200. We know that P times Y have to be equal to 4,200. So thus, we can say that 4,200 divided by Y has to be equal to what? $5.25. So before, we knew that the price level was 5. Now we know it's $5.25. So we can take $5.25 minus 5 divided by 5. New minus old over old. And we basically find out that the inflation rate is 5%, which is exactly the same as the increase in the money supply. Now, if tech progress causes Y to increase by 3%, because remember we were holding Y constant at that 8. If we were to increase it by 3%, then it would become 824. So now when you calculate the inflation rate, you still have the M times V, which is still equal to what? 4,200. But now your Y is slightly different. So now your inflation rate differs. So now you know that your P in the year 2009 is equal to $5.10. So $5.10 minus $5 divided by $5 is 2. Your inflation rate now is not the same as your money supply because there was text progress. So whereas if the money supply was the only thing that changed in an economy and nothing else changed, then yes, that would be true. But one would hope that by increasing the money supply and having more money available, some businesses would use it to invest into technology. And if they invested into technology, that decreases the inflation rate. So you can kind of start to see that the Federal Reserve has their hands full. They have to calculate the inflation rate and predict it based on what they can do, which is the money supply, plus what they think is going to happen in the economy to Y. So if the real GDP is constant, then everything is great. The inflation rate and the money growth are exactly the same. But if the GDP is growing, then the inflation rate is going to be less than the money growth rate. And in our economy, in general, our GDP grows year over year. So we know that our inflation rate will always be less than the money growth rate. And it's up to the Federal Reserve to calculate what that GDP growth is going to be year over year, calculate how much we should grow the money supply year over year in order to keep the inflation rate within the mandates. So because economic growth increases the number of transactions occurred, some money growth is needed for these extra transactions. And excess money growth will cause inflation. So we need to keep the money growth at such a rate that it's keeping inflation within terms. Now, we have learned a lot about the Federal Reserve, and we do know that the Federal Reserve has a mandate in terms of both economic growth in terms of unemployment and economic growth in terms of inflation. And they have to keep those in check. And these will keep coming up time after time in the next few lessons. Hyperinflation is when the inflation rate is out of control. It's usually 50% per month or more. So prices rise when the government prints too much money. Remember back to one of the 10 principles? Excess growth in the money supply always will cause hyperinflation. You always want to keep your money supply, back to the slide before, you want to keep your money supply in line with your growth of your GDP. If you don't, you will have hyperinflation. And that's the reason why the government can't just print money. Now, in Zimbabwe, there was a large government deficit. And part of the reason why was the Zimbabwe creating large quantities of money and created basically hyperinflation. So this is how it went. So in August of 2007, the Zimbabwe dollar per US dollar was about 245. By April of the next year, it was 2,900. I'm sorry, 29,401. By the following, just literally month, we had gone all the way up to 207, 209, 688. And then we were at, literally the next month, we were at 4.5 million Zimbabwe's per dollar. By July, the same year, we were at 26 million. And then when we actually started to fix it by February of 2009, and by September of 2009, we were pretty much, we had started at 245 and we were down to 355. So we were getting in there. During this time, they were literally putting signs up that said things like toilet paper only used in this toilet, no cardboard, no cloth, no Zimbabwe dollars, no newspapers. I mean, people were doing things like this. This is called hyperinflation. Inflation tax. When the tax revenue is inadequate and the ability to borrow is limited, the government may print money to pay for its spending. And this is where you get inflation. And this is why it's called an inflationary tax. Most hyperinflations start this way. So the government basically panics. They say, oh my goodness gracious me, our tax revenue is inadequate. We can't borrow any money. The only way we're going to be able to buy anything is if we make some more money. And what happens is they cause inflation. And by doing so, they literally tax people because their money is worth less. So whereas they didn't necessarily collect tax revenue on the front end, by creating inflation, all the people in the country got taxed because their money is worth less than it was before. And as you can imagine, this inflation really affects anyone who's living on the margin. In the United States, the inflation tax accounts for about less than 3% of the total revenue. So very, very small. And that's the way it's supposed to keep, and which is why there is a mandate on the Federal Reserve. The Fisher effect, got a Nobel Prize for this, is he took the nominal interest rate, the interest rate right now, and it is equal to the inflation rate plus the real interest rate. So what we're saying is in the long run, money is neutral. So a change in money growth affects inflation rate, but not your real interest rate. So the nominal interest rate adjusts 1-for-1 for changes to inflation. This relationship is called the Fisher effect. And this is named after Irving Fisher, who studied it. So how close does Fisher do this? So Fisher's basically looked at the nominal interest rate, the interest rate right now, and he's looked at the inflation rate. And you can see that there's a very close relationship between these variables. The cost of inflation is really one of these things that kind of causes a lot of trouble because there's an inflation fallacy which says that most people think inflation erodes real income. But inflation is generally an increase, in prices of everything we buy and everything we sell. So whereas the price of goods may have increased, the price of your labor has also increased. So in the long run, our real incomes are determined by real variables and not by the inflation rate. So if inflation goes up high at any point in time, this is why the Federal Reserve has the low interest rate mandate, it will adversely affect the economy as well as everyone in the economy, right? Because your dollars will be able to buy less. But if we keep inflation very stable, then every single year, our incomes will be adjusted accordingly, and the effect will be very nominal and will literally be the GDP will offset it. So here is where you have the nominal wage and the consumer price index. Inflation should cause the consumer price index and the nominal wage to rise together in the long run. And in incidents where it doesn't occur, adjustments need to be made. So what are the costs of inflation? Inflation has a few costs, and these are ones that you need to know. Shoe leather costs. Resources wasted as inflation encourages people to reduce their money holdings. If prices are going up, people start to reduce how much money they hold. Given time and adequate costs, a frequent bank withdrawals, people are kind of living on the shoe leather. Shoe leather, basically inferring what? It's inferring that people are living on the edge. So what ends up happening is that we reduce our resources because we withdraw more money to adjust for the inflation, and we are spending more money on those frequent withdrawals. Menu costs. Menu costs is the cost of changing prices. So every single time inflation hits, there's printing of a new menu, mailing of new catalogs, changing of the prices on the website. All of these are menu costs. They're things that have to be changed purely because the cost of the inputs going in cost more. So thus you have to have a higher cost of your output. This allocation of resources from relative price variability. Well, firms don't all raise their prices exactly the same time. So the prices may vary, and it distorts the allocation of resources in the short run. Because if something was imported a year ago, its price may stay stable, whereas something that was just imported last week will go up. So people may start buying things that are cheaper purely because they're misallocating their resources in theory because of the price variability. Confusion and inconvenience. Inflation causes the yardstick to which we measure transactions, right? It changes it. And as it changes it, it basically makes it harder to do long-term planning and compare dollar amounts over time. So whenever inflation is not a steady rate, but is a higher rate, it causes confusion and inconvenience. Tax distortions. We talked about this already. But there's another tax that happens. Inflation makes nominal income grow faster than real income. So your spending power isn't quite the same. So taxes are based on your nominal income, and they're not adjusted for inflation. So because your wages have been adjusted for inflation, but your tax bracket necessarily hasn't, people will, when there is large amounts of inflation, people will end up paying more in taxes because even though their real income, their overall spending power hasn't changed much at all, they have been bumped into a different tax bracket and they end up paying more, or they end up paying more just because they are making more in theory. But that is what they call the tax distortion of inflation. Let's do some tax distortion to see how it goes. So you deposit $1,000 in the bank. The inflation rate is 0. The nominal interest rate is 10. And the second one, we're going to look at when there is inflation. We're going to see how this works. Which case does your real value of your deposit grow the most? Let's take a look. And we're going to assume the tax rate is 25%. Pretty high. In which case do you pay more in taxes? And then we're going to compute the after-tax nominal tax rate. All right, so in which case does the real value of your deposit grow the most? Well, in both cases, your real interest rate is about the same. Because what's happening here is one of these things where, remember when we talked about you would take and you would do the subtraction? This is what happens. Remember, your nominal interest rate is equal to your inflation rate plus your real interest rate, the Fisher effect. So I gave you the nominal interest rate, 10%. I gave you the inflation rate, 0%. And you had to figure out the real interest rate. Well, the real interest rate in this case is 10%. So we know the real interest rate for that one. In the second case, you were also given the nominal interest rate, 20. You were given the inflation rate, 10. You had to figure out the real interest rate. It's 10. So in both cases, the real interest rate is 10. So the real value of deposits grew 10 before taxes. So in this particular case, which case does the real value of your deposit grow the most? It's exactly the same. But you can see that you have to take into account inflation, or else what? Case 2 looked really good, didn't it? But case 2 wasn't any better than case 1. In which case do you pay the most in taxes? Aha. Well, in the first case scenario, you're going to pay $100 in interest income, okay? Because you deposited 1,000. The interest rate was 10. 10 times 1,000 is 100. So in that case, if the tax rate is 25, you're going to pay $25. In the second case, you deposited 1,000. The nominal interest rate was 20%. So you're going to pay $200, and 200 times 25 is 50. So in case 2, you're going to pay more in interest. Now, this is one of those cases where what's happening? The inflation rate is causing you to pay more in taxes when you are actually ending up what? And according to inflation, your money's worth about exactly the same, right? Oh, I calculated it all out for you. You can take a look at that. You can stop the video if you'd like, but basically the calculations are such. You have 1,000, you multiply it by 10%, you get 100. The taxes are 25, so you pay 25. Here, you're basically going to do the same, but it's 1,000 times 20, so you get 200. 200 times 25 is 50. So you're going to pay more taxes in case 2. But remember, case 1 and 2, by the Fisher effect, that 2,000 and 1,000 are worth about the same, aren't they? Compute the after-tax nominal interest rate, then subtract inflation to get the real after-tax interest rate on both. So in this first case, what do we know? We know the tax rate. So we know nominally that we are going to get back, after computing the nominal interest rate, which we have the 10%, and subtracting inflation to get the after-tax. So what do we have? We have no inflation, and we know that we are only going to end up with 75% of what we started with, because 25% is going to go to good old IRS. So if we take 75% of 10, we know we're going to end up with 7.5. Take 7.5 and you subtract out your inflation to get your real, you have 7.5. Now in the second case, we're only going to get 7.5% of our money. We are going to get a 20% nominal interest rate, which means that if you were to calculate it out adjusted, we know that our after-tax interest rate is 15. Real interest rate is 15 minus 10, which is 5. So in case 2, we will end up with less money even after we pay the taxes, partially because of what? Inflation. So I hope by running through the problems, it helps a little bit. It's hard to talk through them without seeing your faces, but I'm hoping that that helped a ton. So in summary, the nominal interest rates, the Fisher effect, they were raised, but the real interest rates were not. The savers had a higher tax burden, as we remembered, and they lowered the after-tax real interest rate. So one of the things you have to make sure that you remember as a consumer is not just to look at the actual interest rate, but to look at the inflation and to look at the tax ramifications of any savings. Now, there's some special costs that are associated with unexpected inflation. So when we get into a situation where inflation occurs and it was unexpected, it can cause a transfer of purchasing power from the creditors to the debitors. People who have to repay their debt in dollars, they're paying them in dollars that aren't worth as much as when they took the debt out. So if you think about it, when inflation rates are lower than expected inflation rates, take the purchasing power and the creditors end up with it, because what ends up happening is now your money kind of keeps the same value and thus you're not getting adjusted by inflation, so you're going to pay. Now, the higher inflation rates are more variable and less predictable than the lower. So these arbitrary reimbursements are frequent when the inflation rate's high, but aren't as infrequent in the inflation rate's low. And I guess what I'm trying to say, and that was really kind of a confusing way of saying it, is if you think about it, and you take a loan out for $100, and you know you have to pay it back $10 a month for 12 months, let's say, because of the interest rate. And the $10 at the beginning, you know what monthlies are going to work, $10 a year. The $10 in the first year, it's $10, right? Well, if inflation rate's high, that $10 isn't worth as much the second year, is it? So even though you have to give the bank $10, the bank is getting a $10 back that doesn't have the same spending power as the first $10. So when inflation is high, frequently, and the interest rate stays about the same, you as a person who holds a debt are paying back with money which is worth less. Now, when inflation is extremely low, this does not work in your favor, but it does work in your favor at high interest rates. The problem is that you have to keep in mind that everything else is getting more costly, and you have to hope that your income is being distributed accordingly. But this is called the arbitrary redistribution of wealth that occurs with unexpected inflation. So to explain inflation in the long run, economists use the theory, quantitative theory of money, which we now know as M times V is equal to Q. I had a space out there. Do we all remember that? Because I'm driving a space out. M times V is equal to P times T. Thank you. When sometimes P becomes Y, T becomes Y, it depends on the economist. So M times V is equal to P times T or Y. And according to this, price levels depend on the quantity of money, and inflation depends on the money's growth. When we look at the dichotomy, we're looking at the basically nominal versus real, and we're looking at the neutrality of money and the idea of the fact that basically money is supplied by its nominal variables, but not by its real. And this is because the relationship between variables doesn't change. The relationship between your pizza and your CD doesn't change even with inflation, because each price is going up about the same. Thanks, guys. I hope this was somewhat helpful. I know it was a very long chapter. I had a few distractions here while I was recording it, so hopefully it was interesting enough, and talk to you guys soon.